Welcome back. In the last video, we covered logistic regression as one of the machine learning algorithms that you can use for classification purpose. We provided 3 resources for you to study more, and we also walked through what the logistic function looks like. It's also called the sigmoid function with this form right here. We plot out what the sigmoid function looks like in terms of its shape, and also provide a representation of what logistic regression looks like. And this second equation here is usually the preferred or more oftenly or frequently used. We also walk through how you actually segregate the so-called output in order to classify it to 2 class, because we are looking at binary. You can set the benchmark as the cutoff point as 0.5, or you can set it as we did at 0.7. So in this lesson here, we're going to walk through and develop further intuition with logistic regression. We're going to show how you can apply it to forecasts, to make predictions, as well as making use of the scikit-learn library to learn from the data, to develop a model and apply it to unseen data. So let's get into it. This is the actual equation that we have earlier, where the y hat is equal to 1 divided by 1 plus this exponential function here, which is minus beta 0 minus beta 1 multiplied by the individual observation itself. Now, the key thing here is that y hat is the predicted value with real value between 0 and 1. I mentioned that in order to convert this to become a binary value of 0 or 1, you need to actually either round it or provide a cutoff point. Now, what we've done so far is just develop a little bit more intuition of and feeling of how logistic regression works. It's basically a sigmoid function with a slight variation in terms of the actual x term itself. And what we're going to do now is, let's just say we've been given some data sets. Okay, so these are the so-called training data sets that you've been given, real world observation. When you observe this value, which is the x1 or xi, you get the y hat is being 0. And this is x, the second x term, you get a so-called y hat value of 0. Let's just say some kind soul, okay, has already done some learning using machine learning, as in machine learning, and already calculated the coefficient. So let's just say, let's say you have been provided with the actual coefficient itself, okay, with the coefficient, and you don't actually have to perform the so-called modeling or so-called estimation yourself. So basically, you've been given beta 0, which is this first term here, and you've been given beta 1. So all that we have to do now is just iterate through, okay, every row and see how well this coefficient actually works. Okay, let's just say all that you know is just this data set. You've been given the first row, the column 1. Okay, you want to see if it actually, in this coefficient here, indeed actually matches the so-called y hat value itself. So what we're going to do is, for each row in the data set itself, we're going to iterate through them one by one, and y hat is equal to 1.0 divided by, basically I'm actually writing this equation here. So it's equal to 1.0 plus numpy, the exponential function. It's a minus, so our coefficient has been given. We're going to take the first coefficient, which is beta 0 here, minus the coefficient 1, and multiply by the so-called row, each row's, the first value of each row. Okay, so now what we have to do is just print the y hat, and we're going to print out the so-called real value itself, up to 4 decimal place, and again y hat. This time we're just going to print the value. Okay, so y hat is the real value, and I do want to round y hat, okay, so that it is a binary value of 0 or 1. So let's print that and see what it looks like. So y hat, the actual real value is this. The actual binary value, because we are rounding it to 0 or 1, we get 0, 0, 0, 0. First 5 is 0, which is exactly that, and 1 all the way through. It looks like the actual coefficient that's been provided by somebody's, or let's just say the Kinsol's coefficient based on their machine learning is correct. Okay, so that's really how you actually run the actual prediction itself. You need to have the beta 0 and beta 1. That's all that you have. You feed that in along with each and every one of the X observation. Okay, so technically I should really write this instead of 1, I should really write this as I. Okay. Now in the real world, you're not going to be given the actual coefficient of either beta 0 or beta 1. You're going to have to estimate it yourself. There are a few ways to actually conduct that estimation. You can make use of the light of maximum likelihood estimation. There are other methods like gradient descent, which is a lot easier as well. So maximum likelihood really is actually quite a common learning algorithm. So basically it's actually try to minimize all the error and try to estimate the actual regression is, the actual coefficient itself. So it's a iterative process to actually find the so-called most likely estimates of the actual coefficient itself. It's quite a complex. There are a lot of math involved using log. I'm not going to go into that. The other way that people quite often actually estimate is using stochastic gradient descent, which is again is an iterative process. You can also use that as well. But in this case, I don't want to actually go into the technicalities of it. We're going to make life a lot simpler. We're just going to make use of scikit-learn of the Python library to actually estimate the coefficient itself. For something as straightforward and as simple as logistic regression, there really is no need for you to actually go and write the estimation, the algorithm itself, or learning algorithm itself. It's already all done for you. Now, however, in saying that, if you're going to go into or developing a new machine learning algorithm, then you may need to actually dig into the math itself. In this case, what we're doing in focus is really on understanding the model and how to apply it in our situation. So as from an application focus, the focus is on the tools rather than the actual mechanics itself. Like you don't need to learn how does the combustion engine works. If you need to just, all you need to do is just learn to drive the car. So this is scikit-learn. I'm just going to import the logistic regression, and I'm going to split our data set. Okay, let me just bring out the data set so that you can actually have a visual. Notice that the data set has two columns. We have the so-called, this is the actual X observations, this is the Y observations. So I'm going to split that into X and Y. Oh, one. Okay, so X looks like this and Y looks like this. Okay, so what we're gonna do next is just build a classifier, and don't worry about the actual parameters, input parameters for now. So we just focus on the instantiation of the classification itself, and we fit the actual model itself. It will give you some feedback. Again, don't worry about that. And all that we have to do next is the actual prediction itself. So basically it's a 1, 2, 3 step process. You have the first one, which is really the instantiation of the actual logistic regression, followed by the actual fitting, followed by the prediction. So what you have is here is that the first 4 terms, it predicted it as 0 correctly. The 5th one is actually wrong. Okay, so it actually estimated as 1 rather than 0, and the remaining portion is 1. Okay, obviously it's wrong, so we need to actually go back and train this model a little bit. But in this case, we won't do that. I'll let you actually play around with that, play around with the tolerance, play around with the actual solver itself. How do you understand all of these different parameters? What we can do, let me just bring up scikit-learn. Okay, so this is the scikit-learn library and the documentation. You can go and have a look at the scikit-learn.org, stable modules, linear model, and logistic regression. But rather than typing all of these out, which is a pain, just Google it, logistic regression, scikit-learn, it will bring it up. So what you have here really is the description of logistic regression. You can either use the L1 regularized logistic regression, or you can use the L2. Just now what we use is the L1. Okay, so you can also use different solver. You can use the linear, the Newton, and a few others. The solver linear use coordinate descent algorithms, and then on it goes, the different type. So it might pay for you to actually play around with it, just to understand, get an intuition of how it works. It also say here for large data set, you might want to consider using SGD classifier with log loss for the actual solver itself. This is the actual, again, this is the documentation itself. Sometimes, as you can see here, logistic regression sometimes called logit or maxent. Maxent is actually explained here earlier. Maximum entropy classification or log linear classifier. And again, there are a little bit more documentation here. I'll leave that with you to actually play around with that. Probably the first thing that you want to actually play around with is the tolerance, and see if it actually improved that. So the tolerance doesn't really improve that. Maybe you need to actually change it to L2. Again, that doesn't work. So obviously it looks like that you do need to play with it a little bit more to actually get a better handle on how to actually get a better estimates. There's just something that I want to actually show you before we go, which is this. The classifier itself has a built-in method called proba. Proba actually is the actual prediction, the continuous variable. So here you have the actual so-called binary value. But remember that when we were doing this earlier, there is actually a continuous variable. Notice that the reason the fifth variable is so hard to predict is because it's really borderline. 4955 is really close. Okay, so that's why the solver is having a problem trying to actually determine what exactly it is, or not getting it right. So here you're looking at this. Notice that the actual probability that's been predicted is 0.61. So obviously it's above 0.5, so that's why the rounding push it up to 1. So this is really one of the ways that you can actually go dig into the prediction itself, play around with it, just to get a much deeper intuition of the so-called how logistic regression actually functions. Now finally, before we move away, if you are one of these people that love to dig into the actual details of linear regression, do make sure that you actually make use of these further resources. Before we move on to working on the real data set of MNIST in the next segment of the video, I'd like to actually try this exercise. I'm giving you a data set called data set 2. This is really a classification exercise. I'd like you to actually walk through the process that we did earlier, which is fitting from taking the raw data, the data sets, and splitting them into X, which is our predictor, and Y, our target, fitting instantiating the model, fitting it, and run your prediction. I'd like you to actually take a couple minutes, pause the video now, and run these data and try it out yourself. And when you come back, I will summarize and compare our results and see the difference. Welcome back. How did that go? I hope you try that out. I'm just going to walk you through and show you my answer or the result that I did. So in essence, we are taking the X from a dataset 2, which is taking column 0 here, and y from column 1, and store it in x and y respectively. We instantiate the logistic regression and fitting it. And the next thing that we did is run a prediction, store our prediction of x into y prediction for use later, and run the actual prediction itself. Notice that I do run it twice, but that's okay. So now the question is, how do I actually compare this against the original dataset, and how well did I do? So let's just use the NumPy stack, and let's just stack them side by side. I'm just taking the y prediction here and also the actual y, and we need to have another bracket. Remember, this is our prediction and this is the actual, and looking at it, you can see that we actually have a perfect prediction. Now that's understandable to a large extent, because we are actually running our prediction using our training set, so naturally you're going to get pretty good fit anyway. But that's really not the point of this exercise. The point of this exercise is just to get you comfortable with logistic regression and using it to run a classification prediction, and just walk through the workflow with you. When you come back, we're going to start working on real datasets called MINS datasets, and can't wait to see you in the next video.